Okay, one other common type of rational equation is one like this, where we have one fraction on the left and one fraction on the right. Okay, the other technique that can be used in this situation can't be used in the other because of the nature of the functions on either side or both. Okay, is that if we have one fraction equaling one fraction, then we can also use the cross product property here. So if I did 6 times x plus 6, and then x times x minus 5, okay, we can also use the cross product property instead of the clearing fractions property, which would ultimately give us 6x plus 36 over here, x squared minus 5x over here. And then if I set all that equal to 0, I get x squared. Then it would be minus 11x minus 36. Turns out in this case, and again, I just made up these numbers, so I wouldn't expect that this factors. If it did, I'd be kind of a genius, but I'm not. So therefore, it doesn't factor. If it would have been a plus, it would have been 9 and 4, or no, that still wouldn't have worked. So either way, it does not factor, so we'd have to use the quadratic formula here to get our solutions. So if we do opposite of b, plus and minus the b squared minus 4 times a, which is 1, times c, which is negative 36, all over 2a. Okay. And we go ahead and calculate our 121, and then it's going to be plus 4 times 36. In our parentheses, we'd get 265. So it'd be 11 plus and minus the square root of 265 over 2. And of course, we'd want to check the 265 and see if it can be broken down at all to simplify that. So we can definitely divide it by 5. So if I go 265 divided by 5, I get 53. 53, however, is prime, so that means it doesn't divide any further. So these would be the two solutions that I would get, okay, for this equation that would supposedly make this sentence true. Okay, and let's go ahead and check that and see if that makes sense with our calculator. So if we graph, again, thinking of bigger picture, we have x minus 5 divided by 6, and then over here we have x plus 6 divided by x. And we graph these two. Let's see what we got here. So the left one is a linear function. It shouldn't be surprising because it's just 1/6 x minus 5/6 if we were to split that up. But it looks like we do see an answer right here. Okay, so let's go ahead and check that one out and see what that one ends up being. So if we do the intersection here, we get negative 2.63941. And to check to make sure that that's actually the right answer here, let's go ahead and get the decimal for this exact answer that we got. So if we do 11 minus radical 65, divide that by 2, okay, we get 65, thank you. So 265, there we go. And then we divide that by 2, we get, there's the negative 2.639 that we expected. Okay. And then in the other one, if we do 11 plus, and we divide that by 2, okay, we should expect an answer of 13.639. Okay. And so that means that we're going to need to open our window up a little bit more, maybe go up to 15 here to see that other intersection point. And it looks like there it is right there. So let's check it out and make sure that that one works as well. And sure does, 13.639. Okay, so that means that both in this case work. Okay, we don't have an extraneous solution this time. We have two valid solutions. Okay. All right. So again, the two main types of equation solving that we have when we deal with rational functions are clearing fractions, and then also using the cross product property if we're given the right situation. Now, we're going to go ahead and take a look at a couple of examples of some real problems, because some of your work today is going to involve some real problems, us writing an equation and then finding the solution or solutions. Okay. So in this case, it says find the dimensions of a rectangle with the minimum perimeter if its area is 300 square meters, and we want to find this least perimeter. Okay. Now, the general theme of any problem where we're trying to find a maximum or a minimum is to first write an equation, okay, that describes the situation. So first of all, we're talking about a rectangle, and we're talking about perimeter. So we know that when we have a rectangle, it has dimensions length and width, and the perimeter is going to be 2L plus 2W, as we know from geometry and lots of other math classes that we've had so far. Okay, and ultimately we want to find the minimum perimeter in this particular case. Now, the main problem that we have though is that if we want to find a minimum, okay, we would like to be able to graph this ultimately, okay, or if it were a parabola, we would be able to find the vertex of it. Okay, but the problem is we have two variables. Okay, so we can't maximize or minimize an equation that has more than one variable. However, they told us that the area is 300, and we know that area is equal to LW. Therefore, we know that 300 equals LW. And what we can do now that we have two equations with two variables is we can solve this equation for one of the two variables and then plug it into the perimeter equation. And so if we do, say, 300 divided by L equals W, okay, we can take that expression and we can plug it in for W. So that means our new equation becomes 2L plus 2 times 300 over L. And why is that helpful? Because now I have the perimeter equation that's written in one variable. Okay. So if I have 2L plus 600 over L equals P. Okay. And then again, the question is, what is going to be the least perimeter? Okay, we want to find the maximum or the minimum of this particular function. In this case, we want to find a minimum. Now, there's really the only way that we can find the minimum for this type of equation with algebra is to use calculus techniques, okay, which we have precisely 0 of. True? Okay. That's actually false. We do know some calculus because we know about limits. Okay. So in this case, though, there's really no algebra way to figure out the minimum of this, so our only choice at this point is to use a calculator. So this would be a calculator problem. And what we'd want to do is go ahead and graph it and see where does it have a maximum or a minimum. Hopefully it has a minimum because that's what we're looking for here. So if we graph this. Now one thing that we want to make sure we're careful with here is figuring out what the window needs to be. So keep in mind x is really the length here. So in my window, I'm going to put 0 to something. Okay, I'm just going to try 0 to 50 here. My perimeter here, of course, is going to be positive as well. So I'm going to go 0 to, let's just say the perimeter is, let's say 200. And again, I'm just guessing here. We may or may not see a picture. We might have to readjust our window after we look and see what we see. But in this case, it turns out there's my P equation, and it does, in fact, have a minimum. Fair enough? Okay. So let's go ahead and find that minimum. You do second calculate, above your trace button, get your minimum command. And if we go over to the left and hit enter, go over to the right of the minimum, hit enter. Go back near the minimum and hit enter again. Okay, we get an L value of 17.321. Keeping in mind this is in meters. And then the perimeter value here is 69.282, also in meters. And again, in this particular case, they just said find this least perimeter. So this P value right here would be our answer. Okay. In some cases, could they ask us for the dimensions? If they wanted the dimensions, we have the length. If we needed the width, we could put the length into our width equation over here and find that as well, if necessary. Okay, we could do that. But ultimately, that would do it. Okay. Now, really, again, the only time that you'd be able to do this with algebra, okay, is if the P equation turned out to be quadratic, okay, which means you could find the vertex. Okay. Otherwise, it's a calculator problem. Okay. Questions on any part of that one? All right, one last problem I want to look at here with you, and that's it's in your book. It's on page 255. We're going to look at number 37. It tells us here that the Drake cannery will pack peaches in 0.5 liter cylindrical cans, and it says let X be the radius of the can in centimeters. Okay. All right, and in part A it says express the surface area of the can as a function of X. So cans that are cylinders. Okay. If we're going to write the surface area for that can, keep in mind that we learned in geometry that if we were to, let's say, cut this down the middle and lay it out, okay, the lateral part would be a rectangle. The one dimension would be the circumference, 2 pi r. The other dimension would be the height of the cylinder. Okay, so that means the lateral area is 2 pi r h. Okay. And then it also has a top and a bottom, which are both circles, and so therefore we'd have 2 pi r squared, and that right there would give us our surface area. So in general, that would be the surface area of a cylinder. Okay. And if we want to find, ultimately in the part B here, it says find the radius and the height of the can where the surface area is 900. Okay. And so if you look at the problem that I'm going to run into here, similar to what I had with the perimeter, is that we have two variables. Okay. So again, it says find the radius and height of the can if the surface area is 900. So we got 2 pi rh plus 2 pi r squared equals 900. And once again, the issue is we can't solve that because we have two variables here. Now, they gave us one other piece of information we haven't used yet. Okay. They told us that the cans are 0.5 liters, and keep in mind that liters is a volume. Okay, and we know that volume in this situation is equal to the area of the base, pi r squared, times the height. Okay, we have a cylinder. The area of the base is pi r squared. The height is h, and we know that that has to equal 1 liter. Now, here's where we have to be careful here because we need to use a conversion. Because if it's 0.5 liters, okay, liters are related to cubic centimeters. By 1 liter equals 1,000 cubic centimeters. So that means that this would ultimately equal 500 cubic centimeters. Because again, they told us that each can was a 0.5 liter can. So half a liter would be 500 cubic centimeters, because again, 1 liter is 1,000 cubic centimeters. Okay. So what does this do for us? Well, it gives us a means to replace one of the variables in this equation and hopefully be able to solve it. So if we do 500 over pi r squared equals h, that'd be the easiest variable to solve for in this case. And then we take that and we put it in for h up top. Then we would have that, and then simplifying, we would have 1,000 over r plus 2 pi r squared equals 900. Okay. Now, in this particular case, once we multiply the 2 times 500, the r and the r squared will cancel and leave us with an r on the bottom. The 2 pi's will cancel. Okay, and so at this point, we're looking for the answer to this sentence. Now, it's a rational equation, so we could theoretically solve this with algebra. However, when we're dealing with a real-life problem like this, they're generally going to ask us for answers to the nearest something or other. So once we see that, then do we need to do any algebra to solve this? No. Okay, then it becomes a straight calculator problem. So again, what are we going to do? We're going to plug this into one side, plug this into y2, find the intersection. Okay, and so when we get done, we'll have a radius of whatever it is. And then we can also find the height because we can plug our radius into this equation and find the height. Okay. We already know what the perimeter is. If they asked us to find the volume, we could find that too because we would know the r and the h, and we could find the volume if necessary. However, we already know what the volume is. It's going to be 500 cubic centimeters. Okay. So with that said, we'd find our r again with the calculator. And if they wanted the height also, we could plug it into the h equation and find it as such. Okay, questions on any part of that process?